Good morning, everyone, and welcome back from the tea break. My name is Craig Pittman, and I'm really excited to be here today amongst all of you to discuss something that David introduced a little bit earlier, and that is how we can build and operate ArcGIS systems, particularly those for enterprise ArcGIS systems that are working here today in India. As we all know, technology is evolving at an unprecedented pace. It's hard to keep up. And the responsibility of building and operating enterprise-grade systems is one that we share together. Esri India, and you, developers, architects, system integrators, IT administrators, DevOps engineers, all of you. Esri is delivering upon our responsibility by providing enterprise-class software, SDKs and APIs. And furthermore, we're publishing opinionated standard architecture patterns and practices that we hope you can all embrace for shared success. So what does opinionated mean? Opinionated architecture patterns and principles are those that Esri India, and indeed the IT industry share. The recommendations, the frameworks, the design principles that guide developers and engineers in structuring systems, applications, code, deployments, and configurations. These patterns are prescriptive, meaning they provide a clear path and advice for developers and engineers to follow, often with very specific conventions and best practices. By taking on these approaches, you can ensure productivity and consistency in your deployments. Now, I also mentioned a shared responsibility, and by that I mean that we, here at Esri, architect ArcGIS using best practices. And we also provide guidance for you to enterprise and architect your systems well. So today, together, let's explore how ArcGIS has evolved into a truly well-architected platform that meets the rigorous demands of modern IT operations. So let's begin first by defining a modern and foundational enterprise GIS system. The core capabilities of our system is enterprise mapping and enterprise analytics, and we saw a few of these highlighted earlier in the last session. Such a system is built on enterprise architecture and works on your data, including enterprise and business data. And it's designed for various user personas and additionally for enterprise automation too. It's a system for delivering emerging and rapidly advancing trends and technologies, including AI. And all of these aspects need to come together for an enterprise-ready and IT-ready system. When we look at ArcGIS as a foundational IT platform, you'll see a complete stack here. Infrastructure, data, services, apps, APIs, and workflows. And we recognize that in implementing systems, you will have many different deployment patterns for your users. And your users may be working in the field, your users might be working in an office or in a headquarters environment. And they will work with different components, including enterprise, online, mobile, web developer, and pro. Indeed, the platform supports all of these seamlessly and performantly. It is scalable, secure, reliable, and interoperable. We call it a well-architected platform to support your mission-critical systems and your applications. And as David said, technology alone isn't enough. It's enabled by people and processes, including considering the strategy, governance, adoption and rollouts, and capacity building. So today, we see you taking this ArcGIS technology platform and applying it within your business and enterprise IT environments, integrating with them, and transforming it into purpose-built systems that solve real business problems. Systems like the ones you see here, a network management system, a land management system, airport safety systems, damage assessment systems. And these systems are enterprise ready and follow enterprise IT standards. We define a well-architected system as a set of system patterns. Patterns are recipes for how you can assemble the ArcGIS platform and its components to deliver specific types of systems, including imagery or mobile systems. When following these recipes, we have a number of considerations, or pillars, that are increasingly important for building and operating mission-critical systems, including considerations around observability, integration, security, and extensibility. We're going to demonstrate to you today how IT system pillars can be applied in practice, so when developing and engineering systems, they meet these requirements and expectations of our users. Here you see the conceptual diagram that David introduced earlier that conveys the tiers of a well-architected system. And this is consistent for both software product deployments and for SaaS systems. I'd like to draw your attention to the right of this diagram. The platform now has geospatial AI capabilities, including AI models and AI agents fully integrated into the system. This enables agentic AI into enterprise workflows. This is an example of how the ArcGIS platform continues to evolve every year to introduce emerging capabilities alongside our core data mapping, visualization, and analysis capabilities. So let's zoom in a little bit and consider, for a business and mission-critical IT system, ArcGIS doesn't exist in isolation. It needs to integrate with other systems. And let's look at this first. When working in these enterprise environments, ArcGIS does integrate with systems from Salesforce, Microsoft, SAP, ServiceNow, AWS, IBM, Autodesk, Trimble, and Adobe. Many of these out of the box, ready to go. And they are directly supported, existing as well-integrated systems. Some of you may already be using these integrations for asset management, work management, AEC, and so much more. Esri India, Esri and yourselves are interconnecting and geo-enabling these enterprise business workflows, bringing location intelligence to where the business processes live. There are business systems that require business or domain-specific customizations and integrations, where you have a need to extend ArcGIS into these IT systems. So let me break these down into three primary approaches for integration. Firstly, integration or integrate. Secondly, extend. And lastly, intercept. Firstly, integrating using APIs and webhooks. These are the connection points to external systems. Secondly, extending the platform with custom geoprocessing tools custom AI models, server object extensions, and custom data feeds. And thirdly, by intercepting requests and responses using server object interceptors and service interceptors. Let me show you in a slightly more technical way. Here's a visual representation with the different software components that ship with ArcGIS Enterprise. In the center, you can see both ArcGIS Server and Portal for ArcGIS. And around this, you can see the three patterns: extend, intercept, and integrate. You can extend Portal and integrate with other systems using organization webhooks. And similarly for ArcGIS Server with feature service webhooks, geoprocessing service webhooks, and using ArcGIS notebooks as webhook receivers, making this technology responsive to requests and actions and triggers from other systems. You also have the ability to develop extensions like SOEs for Map Server and Image Server, or custom geoprocessing tools, GeoAI models, and custom data feeds. This is about introducing additional capabilities to the core ArcGIS technology and having this capability available to all your users without dramatically changing an architecture or end-user apps. And thirdly, interceptors, including SOIs for Map Server and service interceptors for Portal that let you intercept and modify requests from your apps. So let me introduce my colleague Ishika, who is going to demonstrate this third extensibility path of intercept. Now, Ishika is going to take on multiple roles in this demonstration, so please watch closely to see how different business system users will benefit from their ArcGIS and Salesforce systems integrating.
ArcGIS is the spatial system of record for a commercial property insurance portfolio. The application shows commercial property with the policy status, the critical layers, and other demographics. This data is important for risk assessment and better decision making. On the other hand, sales team uses Salesforce to manage customer accounts, policies, and new opportunities. When a new insurance opportunity comes in, Salesforce account usually has the address details only. Without this spatial context, analysts must do a lot of manual work before making final policy decisions. The requirement here is to keep ArcGIS and Salesforce aligned, and that is where a service interceptor comes in. It is a new extendability pattern that allows custom code to run within an ArcGIS server services at a request and response level. Let's take a quick look at the code behind this integration. As a developer, I built this using ArcGIS Enterprise SDK for .NET as a server object interceptor, or SOI, the intercept request in real time. Here is the SOI integration, attributes behind the interceptor, directly to the feature server services, allowing it to sit in line with every request made to the services. The key method here is the handle REST request. This executes every time a REST request hit the services and is where the interception logic begins. For incoming request, the logic first check whether the operation is in the apply edits, meaning a feature is being updated or submitted from the GIS application. Once the edit is detected, the interceptor reads the payload and enrich it with the location, intelligence, and risk attributes, such as the last inspection date, fire station proximity, flood zone proximity, crime rate, and calculated risk score. Rather than just storing edits in GIS, the interceptor immediately pushes this enriched information into Salesforce using a live API integration, keeping both systems synchronized at the moment of inspection. The field mapping logic ensures that GIS attribute are transformed into Salesforce business field, while adding dynamic values like inspection date, computed risk metrics before sending the updates. Finally, the project is compiled and packaged as a deployable .NET SOI assembly, ready to be registered with ArcGIS Enterprise and attached to the map services. Now, as an ArcGIS server administrator, I am going to enable this interceptor file and registering it with ArcGIS server. The deployment here is very easy. I have already logged in to my ArcGIS server manager. Here you can click on this add extension and select your compiled file and add it here. As I have already selected my file, then you can simply go back to your services where you can see the name of your layer already being published. As soon as you click on your published map services, you will see the capability option. Under the capability, you will find your interceptor available. With a single click, you can enable this interceptor. At this point, the interceptor is fully operational, no downtime. You can simply save and restart it. Now let's see this in an action. Switching back to the field inspector role, the inspector is already on site, which has an account in Salesforce with address detail, and now he is going to update the inspection details such as the roof condition, the number of floors, fire hazard rating, and building age. Now I'm going to change the policy status of the same property to the inspection completed, which complete my work here, and it is also signaling that interceptor has executed in the background. Now we are going to see this impact in the Salesforce. Once you refresh this entire page, you will see now your property inspection details are populated. Within the scroll, you can see the location intelligence details such as fire station proximity, crime rate, flood zone proximity, risk score. They are also populated, even though I did not enter them in my application form update. The service interceptor calculated those values from available ArcGIS spatial layers and sent them to Salesforce in real time. All of that happened during request interception. This is how a service interceptor keeps the two systems, GIS and Salesforce, synchronized and connected. In summary, the service interceptor provides a lightweight and a powerful way to connect ArcGIS Enterprise with various business systems without changing the client app or modifying the backend services. Thank you, and back to you, Craig.
Thank you, Ashika. That was an excellent demonstration of how service interceptors can seamlessly bridge ArcGIS and enterprise CRM systems like Salesforce. Now, I saw how you took on multiple roles in that demonstration, and it's a powerful way of how different business system users can benefit from this integration and get maximum business use out of enterprise investments, whilst also keeping the data consistent throughout. So this kind of integration means your field teams can work in the tools that they're familiar with, on the devices that they need to work with, and while automatically keeping their critical business data synchronized across multiple systems. Let me summarize. Number one, as shown here, an ArcGIS-powered application allowing users in the field to apply edits and receive enriched responses. And number two, Salesforce users seeing updates and rich ArcGIS information, all while keeping the information consistent and synchronized. Next, let's talk about arguably the most important pillar, reliability. Increasingly, organizations depend upon enterprise GIS for mission and business critical needs. And when these systems go down, operations can stop, decisions can't be made, and in some cases, lives can be at risk. So reliability isn't just a nice to have. It's a foundational principle for any enterprise IT system. Of course, if you're waiting for your users to tell you that your system isn't available or reliable, you've already got a problem. So that's why your system must also be observable and monitored. Similarly, you should engineer your system to scale and to meet demand and ensure performance expectations are met, or perhaps to optimize cloud infrastructure costs. Today, I'd like to introduce my colleague and friend, Nitin Chauhan, who would like to explain how ArcGIS powers reliable, observable, and scalable systems using modern, cloud-native, and optimized technology.
So, good afternoon, everyone. Many of you have already learned that ArcGIS Enterprise on Kubernetes, it provides a modern and cloud-native enterprise GIS. So the ArcGIS Enterprise capabilities which you have been using so far on the Windows and the Linux editions are broken down into purpose-built microservices. Now what that do to you? It helps you to scale and be resilient, as these are packaged as containers and deployed against a distributed operating system, that is Kubernetes. And since it is standard, so we are able to run it across many cloud platforms in a native manner. For the developers, that is you, it has powerful DevOps automation support to help you manage the system using Helms, for example. So when you deploy enterprise Kubernetes, your default deployment is always well architected. Standard availability, which is the default profile, it provides you the compute and storage in a replicated manner to support your continued use in the event of any unexpected downtime or failure. In enhanced availability, there is even more redundancy as you get multi-AZ support in the cloud, for example, for deploying your Kubernetes cluster that spans across availability zones, which you can understand as data centers. I want to highlight for everyone here that frequent backups have always been important, but they are even more critical given the current incidents which happens in the IT industry. So there are two prominent matrices which generally come across whenever you are looking for scalability and reliability, that is the RPO and the RTO. RPO is recovery point objective, which measures how much data loss organization can tolerate or business can tolerate, and recovery time objective measures how quickly you can recover from a disaster. So with the newest release of ArcGIS Kubernetes, now we have enabled with the newest release of ArcGIS, we have integrated disaster recovery as a part of the enhanced availability, so that your system, while it is present in a primary zone, it has a hot standby on the other region as well. So when you are running a reliable, enhanced, high availability system, you can spread your cluster across multiple availability zones like you see over here. Notice that every capability or the service is spread and replicated across the AZs. So in case one of the availability zone goes down, then the remaining will rebalance. So as I said, with the enhanced availability, we have extended the concept not just across the AZ, but we have enabled a hot standby across the region as well. So if you see on the top, the global load balancer or the traffic manager, it routes all the traffic to the primary region, but the moment the primary region goes down, your secondary region, the global traffic manager detects the failure and route all the traffic to the secondary region. So in past, we have seen that the reliability in the midst of node failures, availability zone failures, and last year it was region failures. So when it comes to performance and scalability, those all of you who are using the cloud, you are well versed with the technology of auto scaling, which helps you node level auto scaling in cloud native architectures. In Kubernetes, you can scale your pods vertically, that is, you can increase the CPU and the RAM as per need. or you can increase the number of the pods which are serving a particular capability by increasing the number of pods. The update that I want to share with you this year is our introduction to cluster level auto scaling. So ArcGIS Enterprise interoperates with Carpenter, that is an open source and high performance technology that many enterprise systems already use today for their Kubernetes deployment. This means that you can strike the correct balance between scaling up based upon your demand and maintaining the cloud cost. So let me show you that what auto scaling looks like for a cloud administrator. So here you can see this is a Grafana dashboard, and it visualizes basically the errors, the performance, the load, and the utilization live metrics. So you can see here in the load simulation test, we have increased the number of service requests over 15 minutes period, which is seen in blue. ArcGIS Enterprise responded automatically by adding more pods to the service these requests as they are shown in green. Even when you have more need for the resources, then pods will come up, the new pods will come up, and they will balance the requests. If you see in the performance tab, the most promising things what we require from a user perspective is that our user should have the response in a very limited, in a very small time. So you can see that in the beginning the response time was large, but as the pods and nodes get balanced out, then you will get a more frequent response.
Globally, we're seeing significant growth in demand for GIS and mapping systems, especially from organizations who demand high levels of reliability. As an option, ArcGIS Enterprise on Kubernetes can power these systems and bring the scalability and observability that all enterprise systems should exhibit. And I'd like to confirm that your choice of cloud infrastructure here will enable you to meet the data sovereignty and residency requirements that you may be needing to address. So now let's focus specifically on the scalability pillar and see how it can be applied to our traditional GIS and imagery workflows. Now, since we met last year, our engineering team has worked on further enhancement to feature services that many of you use for visualizing, analysis, and of course, editing. This includes intelligent caching and has a last edit time on the data set. This enables the system to respond faster, up to 2 times, when a client resends a query, by not fetching all the data every single time. Next, the ability to cache these query responses for the requests so that subsequent queries from multiple clients can be more rapidly returned. And lastly, our support for Content Delivery Network, or CDN technology, for both ArcGIS Online and ArcGIS Enterprise ensures that applications globally can respond rapidly to very large audiences at any time. Looking specifically at raster and distributed raster analytics, I'd like to talk now about how raster analytics can scale to support real workloads. I'd like to use 2 examples here. Firstly, how we can create multispectral, seasonal composite imagery from various sources, including the harmonized Landsat Sentinel-2 dataset. Secondly, how we can perform land use classification at massive scale using GeoAI models with GPU-enabled nodes. Both of these leverage ArcGIS Enterprise on Kubernetes, which Nitin just introduced. Let's welcome Sribhadra to show us how ArcGIS Enterprise can scale using both CPUs and GPUs to complete large workloads in reduced timeframes.
Thanks, Greg. India being a country with many states depending upon agriculture, estimating crop health can help improve crop yield and support farmers. This layer highlights the district-wise crop health statistics in Uttar Pradesh, where the green color represents the healthiest crop. This is the result for 2026 and here is the result for 2025. At first glance, you would not be able to see any difference, but these highlighted states had a decrease in crop health between 2025 and 2026. Uttar Pradesh is the fourth largest state in our country, covering an area of around 240,000 square kilometer. So estimating crop health over the entire area raises performance and scalability challenges. And that's where the power of scalable raster analytics in ArcGIS Enterprise comes. Let's see how we tackle this challenge. We discovered the harmonized Landsat and Sentinel-2 imagery for Uttar Pradesh using the stack experience in ArcGIS Pro. We added the imagery to a mosaic dataset and eventually this collection is published as an image service, keeping the imagery both streamed and centralized. So the analysis takes place right next to where the data resides, and that's what lets the analysis scale more cleanly. The analysis workflow is done in an ArcGIS notebook, in an ArcGIS Enterprise, with the raster analysis executed in the image server. We begin by loading the imagery, boundaries, and other layers required for the analysis. From here, the first major compute step is creating a consistent seasonal imagery. When satellite images are covered with cloud, we won't be able to clearly distinguish between the land use. So, in this step, we create a cloud-free multispectral composite for the Rabi season for the year 2025 and 2026. And here is the result. We got the result for 2025 and 2026. You can see that we got a very clear satellite imagery ready for the analysis. For the entire Uttar Pradesh, this is a CPU-intensive work, but ArcGIS Enterprise scales it across multiple CPU nodes, cutting down the processing time significantly when scaling from 25 CPUs to 200 CPU nodes, which allowed this analysis to run within 1 hour 46 minutes. Now, as we have our cloud composite ready, we can move into AI-driven classification. Here, we create a land cover map using the land use land cover pre-trained model from the Living Atlas. The goal is to create a reliable agriculture area mask so that we can compute the vegetation indices only on the true agriculture regions. How much time do you think it would have taken to generate this land cover map for the entire Uttar Pradesh? With just 5 GPUs, it would have taken 5 hours 29 minutes. But as we scale up raster analytics using 40 GPU nodes for an area of around 240,000 square kilometer, we got the land cover map in just 45 minutes. It's interesting, right? Now, as we have our land cover map, we can compute the crop health using normalized difference vegetation index. We also applied the agriculture area mask so that we can reduce the noise coming from the other land use areas. We computed the vegetation index for 2 years, for 2025 and 2026. Finally, we aggregate the result to the district layer, turning the pixel level analytics into management ready summaries. So the final question is, how does all this behave under real load? That's the power of scalable raster analytics in ArcGIS Enterprise. We can scale GPU and CPU compute across multiple distributed nodes so that large workflows can finish in hours instead of days. Essentially, ArcGIS Enterprise combines centralized imagery, distributed CPU and GPU processing, and scalable analytics to turn massive data into quick actionable intelligence. Thank you. Over to you, Greg.
I'd like to return to these 2 infographics from Sri Badra's notebook. Firstly, Sri Badra and our colleagues were able to scale and be more responsive to the request for seasonal and monthly cloud-free composite imagery. They were able to do this by rapidly adding more CPU-powered instances to a Kubernetes cluster. And you can see here how we were able to create cloud-free multispectral imagery for the entire state of Uttar Pradesh in less than 2 hours. These performance numbers are impressive and demonstrate the true power of cloud-native scalable architecture. And of course, even more modern, we can take advantage of GPUs for faster analysis, including leveraging these for the land use classification from the harmonized Landsat Sentinel-2 dataset from STAC. Processing 1,200 images to arrive at an incredibly useful dataset for an agricultural or a government organization. Now, as you can see, by scaling GPU resources, we can bring processing time down from 5.5 hours to less than 45 minutes, enabling near real-time analytics on massive datasets. Now, whether you're processing billions or trillions of pixels for environmental monitoring, land use classification, or perhaps disaster response, ArcGIS Enterprise can scale to process this much faster. Next, I'd like to talk about automation. Now, as an engineer or developer, you may be called upon within your organization to streamline and automate many of the repetitive tasks that occur. This may be to enhance efficiencies, or it may be to integrate with other systems. Automation is often related to integration, as you've seen, and it also encompasses the governance, compliance, change management, and operational efficiency requirements of an organization. ArcGIS has many techniques, tools, and APIs for automation within and across systems. Your infrastructure and DevOps workflows can be automated using Helm charts, CloudFormation templates, and so on. Or you can use Python API or ArcPy within hosted or scheduled notebooks to automate workflows, or use event-driven webhooks to chain and automate your business workloads. But for today, we would like to focus on governance. To show us how you can automate many of the checks and requirements for your data and meet the policies that may exist, I'd like to introduce Jitendra.
All of you deeply care about protecting data integrity. Today, I want to walk you through a simple yet powerful idea: governance through automation. Using ArcGIS Enterprise, we can turn this idea into reality. Conformance means that anything shared publicly must meet defined standards. But how can we enforce these standards when a user attempts to share an item publicly? Can everyone see the problem with the feature layer that I have here? It's incomplete, poorly classified, maybe missing key metadata, and if I was to share this with everyone, imagine the impact it would have on the integrity of the data. So how do we prevent that? This is where automation steps in. We have configured a notebook in ArcGIS Enterprise that's connected to organizational webhooks. That means that every time an item is updated or shared, this notebook is triggered automatically without any manual intervention. This notebook now acts as a gatekeeper. It checks for metadata completeness, where it checks for title length, length of the description, and minimum tag count. Then it verifies if the item has approved classification tag from the approved list. Then it checks for item completeness with additional checks for feature layers, where for each layer, it looks at the pop-up configurations and also if the layers have a valid extent. If everything looks good, the process continues seamlessly. But if something's wrong, the system responds instantly. In this example, a feature layer didn't meet the required standards. The automation immediately stepped in. It unshared the item, logged the results to an audit feature layer, and then sent the user a detailed email explaining what exactly went wrong and how to fix it. No ambiguity, no delays, just clear, actionable feedback. Yes, and one last thing. We know that many users barely document their hosted feature layers. As you can see here, the description is missing, metadata is incomplete, and context is lost. To address this, the ArcGIS Enterprise and ArcGIS Online now include a beta release of an AI-powered item details assistant. This supports your users in documenting their feature layers to the standards your organization may require. The item details assistant securely inspects the feature layer and makes suggestions on how this layer could be better documented. Of course, this saves time for your publishers of data and makes their data authoritative. So this looks more like a detailed description of the feature layer. I'm sure users would find this helpful. Of course, AI content may need some slight adjustments, and I might like to edit some text in the description. Then I save this information for my audience. That's how you can combine ArcGIS and AI, not just to automate governance, but also to truly enable it, ensuring your organization consistently meets its standards with clarity, efficiency, and confidence. Thank you. Over to you, Troy.
Thank you, Jitendra. Your demonstration shows how automation isn't just about efficiency. It's also about governance, compliance, and ensuring that your ArcGIS systems and the users operate according to organizational policies. Automating workflows means fewer manual errors, faster response times, and easier audits. You showed conformance by using webhooks and email to ensure portal content conforms to organizational standards. But you also showed the AI assistant, which we believe to be a game changer for GIS publishers. And it may be better and more harmonious to help people write good metadata when publishing, rather than allow a wider audience to work with poorly documented data. The Beta AI Assistant is already available to you today in ArcGIS Online and ArcGIS Enterprise 12. So I'd now like to talk about how you, as a developer or engineer, can draw upon new capabilities in ArcGIS, including knowledge graphs, and how you may introduce your own capabilities by interacting perhaps with new data formats. ArcGIS Enterprise, shown here on the left, brings together many different types of spatial and aspatial data, abstracted as web maps, web scenes, and web tools. The introduction of both data pipelines and your ability to develop custom data plugins enable the platform to interact with wider variety of data without necessarily duplicating that data into another system. On the right, you can work with intelligent sources and structured data using Notebook Server and knowledge graphs. So to show you how this might work in your organization, let me introduce Suranya.
Thanks, Craig. For Land Records Department or any local government, managing land parcel and taxation is a crucial workflow. But the data is rarely located in a single system. Today I'm going to show you two methods with which you can integrate your data with ArcGIS, how you can prepare your data for analysis. We will see how we can understand the interconnectivities that exist in the data using knowledge graphs, and how custom agents can help users answer questions about their land records data. So let's begin. So here I have a subset of land parcel data in Kerala, New Delhi. It is stored in an enterprise geodatabase. So the first method is to register your geodatabase with ArcGIS and publish the feature layers. Second, talking about the taxation, tax information is rarely stored with the same department. It is stored with the local municipalities, municipal corporations, or local bodies. And it is usually stored in their own storage. So to simulate this, I have the property tax information in MongoDB. I want ArcGIS to have access to this data, but I don't want to create a copy of it. So this is where custom data plugins came into play. So here I have a custom data plugin project where I have a node.js code. So this connects to the MongoDB, iterates through all the tables in the records, and converts them to GeoJSON. Now this can be converted into a .cdpk file and registered with ArcGIS server under custom data feeds. Now custom data feed is an extensibility option that helps you create feature services referencing to the tables that are not natively stored in ArcGIS. So that is what we saw today, and from here you can publish the feature services. So now we have the land parcel data, now we have the taxation data. Third, I want to know about the flood related information. So I receive a flood polygon from the local disaster management authority at regular intervals. So to do this pipeline, I'm using ArcGIS data pipeline, which fetches the flood polygons, clips it to the relevant boundary, and pushes it as a feature service in ArcGIS. Data pipeline is a web application that not only automates your ETL workflows, but also enables you to bring data from other sources such as file shares, cloud storage, databases, or other ArcGIS feature layers. Now we have all the data. This is where things get complex, right? We have spatial data as well as non-spatial data. If we have to connect all of them, I usually have to perform multiple joins, which can be time consuming. There is an efficient way to do this, which is using ArcGIS Knowledge Graph. Knowledge Graph transforms your data into entity and relationships so that the interconnectivities become easy to understand. To do this, in ArcGIS Notebooks, I'm using ArcGIS API for Python to create a knowledge graph. So here I have already created one, loaded the entities and the relationships, and this is the summary of it. So these are the entities I have: land record, tax related information, violation, easements, flood. Similarly, the relationships are has, tax bill, and so on. Now how do I query this? To do this, you can use Knowledge Studio. Knowledge Studio is an application that helps you to understand your knowledge graphs and ask questions related to it. For example, here when you select on any of the land record, you can understand the properties, relationships. You can add it to a link chart, do on-the-fly analysis to expand them, to understand all the interconnectivities. You can see that as I expand, it brings out all the links that are present in that particular land record. So when you query a relational database, you use SQL, right? Similarly, for knowledge graph, we need to use a special query language called OpenCipher queries. Now, if I want this capability for all the members in my organization, how can I simplify it? This is where agents come into play. So here I have created a land records agent that can convert a simple question I ask into an OpenCipher query, hit the knowledge graph, and respond back in simple English. For example, here I have asked, find the parcel with easement and lane. It generated this graph query and gave the outputs. So these are the parcels which has both easement and lane. Similarly, you can expand the query to add spatial components like what are all the commercial parcels in the flood zone, or if you want to understand if an ownership changes, what all the records that gets affected. In future releases of enterprise, these AI components will be integrated so that you can build your own AI applications as well. So to summarize, we saw how we can bring data into ArcGIS using enterprise geodatabase, how you can bring data outside from ArcGIS but integrate through custom data plugins. We saw how to automate the ETL pipelines using ArcGIS data pipelines. We also understood how knowledge graph help us understand the interconnectivities in the data and how custom agents can give us a simple interface to ask questions about the land records. And thank you. Over to you, Craig.
Thank you, Saranya. Your work here shows the future of enterprise GIS with powerful visual workflows and systems that don't just store, duplicate, or visualize data, but they understand it, they can reason with it, and perhaps take intelligent action. Knowledge graphs and now agentic AI represents a fundamental shift in how we interact with geospatial information and indeed with all our systems. So my 5 colleagues today have taken ArcGIS as a foundational geospatial and AI platform and demonstrated not only how it interacts with enterprise systems, but also how it interacts and extends enterprise data, enterprise services, and other enterprise systems, using the concepts of intercept, integrate, and extend. Together, we've also explained how our engineers have developed this system in a well-architected manner. Furthermore, Esri and Esri India are here to help you build well-architected enterprise systems, IT systems, and business systems. As I said at the start, we see these systems as a shared responsibility, and together, we're not just building systems, we're architecting the future of intelligent, resilient, and integrated geospatial enterprises.